All right, welcome to the Unit 1 retest test review. Starting with these graphs here, we are trying to determine whether these graphs represent a function. When we have a graph, we use the vertical line test to determine if they are functions or not. And the vertical line test says if I draw a vertical line anywhere on the graph, in order for it to be a function, our vertical line can only pass through the graph one time. Notice how my three vertical lines here all pass through the graph twice, so this is not a function. Same thing here, passes twice, not a function. This one passes once, function. The circle graph passes twice, not a function. This one, now that we're at these tables, anytime you have a table, we want to look at the x values, and we want the x values to not repeat. In order for it to be a function, x values cannot repeat. Here we have 5 and 5, so those x values repeat. It is not a function. And this last one, we have -2, 0, 2, 1. None of those x values repeat, so that is a function. All right, moving forward, which of these relations describes a function? Again, we're looking at the x values, and a coordinate is always x comma y. So we're looking at the first number in each coordinate pair. And we're looking for all of these if there's any repeating numbers. Here we have 0, 0, not a function. 2, 2, not a function. 2, 2, again, not a function. Here we have -2, -3, 2, -3. There is our function right here. All right, for number 8, add another ordered pair to this relation that would make this not a function anymore. So what it's saying is that it's currently a function, and we want to add another ordered pair that would make this not a function. So again, we have 5, 8, 7, 0, and 10. So listing any point that starts with any of these numbers would be the way to say, to make this not a function. So we could say 5, 2, we could say 8 something, we could say 7 something. It could be anything. As long as they start with the same x value, it would make this not a function anymore. All right, for this next one, this is we are writing domain and range in set notation. And we said set notation, set squiggly, so we need to write with our squiggly brackets here. For the domain, this represents the x values from left to right, and the range represents the y values from bottom to top. But because we're not looking at an actual graph here, we just want to list all the x values or y values from least to greatest. So starting with the x values, we're focusing 3, 1, 2, 3, 4. So out of these x values, what is the smallest number? The smallest number here is 1. The next smallest number is 2. Then we have 2 3s, but we only list it one time. We don't need to list it more than once. So we just say 3 and then 4. Oh, right. Sorry. In Algebra 2, we use x and then this little bar here. All right, for the range, we say y with a little bar, and then we list all the y values from least to greatest. So we have 2, -1, -4, -9, and -16. So which is the smallest number? -16. Then we have -9. Then -4, then -1, and then +2. Does this relation represent a function? Well, we need the x values to not repeat, and the x value right here, we said 3 and 3 repeat, so this is not a function. All All right, next we have the domain and range of the relation graphed. Okay, so again, the x values are from left to right, and the range is the y values from bottom to top. So starting from the left, going towards the right, our first point is right here, going through the -2. So our graph begins with -2, and then we move on. Oh, our next point is at the x value of 1. Our next point is at the x value of 2. And our last point is at the x value of 6. For the range, we start with y. And going from bottom to top, our lowest y value is -5. As we continue up, our next is at -1. Next point at 2. And our last ones are at 3. Again, we only list them once. We don't need to list them twice if there's 2 points there. All right, our next question is, does this represent a function? You know what we're going to do. We're drawing those vertical lines. And right here, you'd see that that vertical line passes twice. So it is not a function. All right, moving along. Write the domain and range in inequality notation. Inequality notation, oh look, hinted right here. We use the inequalities, less than or greater than. I'm sorry, less than or equal to. Now, we're writing domain and range. Domain is all of the x values from left to right, and range is all of the y values from bottom to top. So looking at the x values from left to right, what is our lowest x value of this graph? It's going to begin right here at 0. Now our second question is there a hole or gap here at 0? No, it's a closed circle, so we use a bracket. As the x values increase, what is the highest x value of our graph? It is right here at 6. And it is a closed circle, so again we use a bracket. Oh my gosh, I'm writing the wrong notation. I'm so sorry. We're just going to fix this. That's if I wanted to use interval notation, which is on the next problem. So I apologize for my mistake. Let's fix it really quick. We're using inequality notation. So for the domain, we have the x in the middle. Our lowest point we said was 0, and it is a closed circle. When it is a closed circle, we use less than or equal to. And when it is an open circle, we use less than or infinity. Okay. So it starts at 0, it ends at 6. So we use less than or equal to. The holes or circles are closed, they're colored in. All right, now for the range from bottom to top, this is the y values. So going from bottom to top, what is our lowest y value? It's right here at 0. Again, it's a closed circle, so we use less than or equal to. And as the y values increase, our highest point of this graph, it says, is at 9. Now, is there an open circle there? No, so we use less than or equal to. All right, looking at the next image here, starting with the domain here, now we're using interval notation like I accidentally did on that last problem. Domain is all of the x values from left to right, and the range is the y from bottom to top. So starting from the left, our lowest x value here is this point, which we can assume is about -6. And is there an open circle here at -6? No, it's a closed circle, so we use a bracket. As the x values increase, where is our graph heading? It's about here. That is the worst straight line ever. It's about here. And we could say, let's just say 1, 2, 3, 4. No, I feel like I'm not trying those separated enough. 1, 2, 3, 4. Okay, we're just going to say it's 4. We're going to say this point here is at 4. And is there an open circle? No. So we use the brackets. And we can make a little note here. Brackets are for closed circles, and parentheses, oh, the worst parentheses. Parentheses are for open circles or infinity. All right, now for the range from bottom to top, where's our y-axis? Right here. So as these y values increase, what is our lowest point? It's right here at about -1. Again, closed circle right here at -1, so we use a bracket. As those y values increase, our highest point here is at 5, 6, 7, 8. Closed circle, we use a bracket. Number 13, write the domain and range in inequality notation. Okay, same as above with the less than or equal to. So, domain, x values from left to right. Range, y values from bottom to top. So, as the x values increase, I look at our lowest point here, and it's an arrow. So that means we're starting at negative infinity. So we say less than. As the x values increase, where is our graph headed? Positive infinity. It's the arrow. All right, now for the range. As our y values increase, where is our graph headed? Look, arrow. So we start at negative infinity. And again, as the y values increase, arrow, we're heading towards positive infinity. All right, now for number 14, we want interval notation, so we're using brackets or parentheses again. So the domain, again, x values from left to right, range, y values from bottom to top. From left to right, as we go this way, it looks like our graph is beginning here. But you have to remember, this is just a snapshot or a screenshot of this graph. If this graph ended right here at 5 and -6, there would be dots here. Because this is just a little screenshot of this entire graph, this graph is going up infinitely. So back to our domain, as the x values increase, we look up and we see that this graph is going infinitely in both directions. So we're beginning at negative infinity, and we're heading towards positive infinity. Now for the range from bottom to top, as the y values increase, where does our graph begin? At -2. There is not an open circle here. There's also not a closed dot here. But because there is no gap or open circle, we will still use the bracket because this is considered an included point. Even though there's not a specific dot there saying, hey, this is a point, it's still a point on this graph. So we use a bracket. And as the graph increases, or sorry, the y values increase, our parabola is heading towards positive infinity, where we use the parentheses. All right, number 15. On each graph, identify and label the following key features when applicable. Write the coordinate point x, y on the space provided. All right, so we need to identify these and then write the points here. So let's start with the x-intercept. Here's the x-axis. X-intercept is where our graph passes the x-axis. It tells us the points here are -2.871. So we'll say -2.871, 0, and the other point is here, 0.871, 0. All right. Those are our two x-intercepts. Now for the y-intercept, where does our graph cross the y-axis? Right here at 0, -5. As for the vertex, that is where our graph is at a high point or a minimum point, and kind of like where the graph begins or where the graph changes direction. So the vertex is going to be here at -1, -5, 6. Oh, look, it has it right here. -1, -7. -1, -7. Okay? Yeah, 5, 6, 7. Yeah, that would definitely be 7. All right. Do we have a maximum or minimum point? We have a minimum point, no maximum here. We know that because when the graph hangs like this is a low point or minimum, and the graph hangs like this is a high point on the graph or a maximum. All right, axis of symmetry. Symmetry, what does that mean? It means both sides are the same, right? So here is our axis of symmetry going right through the center of the parabola. And when we describe the axis, or when we write the equation of the axis of symmetry, this is a vertical line going through the x-axis. We say x equals, and then we name the point on the x-axis that this symmetrical line is going through. It is going through about -1 right there. Oh, and I forgot to list the minimum value. Minimum value or maximum value on a parabola is just going to be your vertex. Okay. Number 16. X-intercepts. Here we have this point and this point. Here's our x-axis and our y-axis. So we can list these 2 points as the x-intercepts. -0.581, 0, and 2.581, 0. Okay, y-intercept, where does our graph cross the y-axis? Right here at 0, 3. And the vertex, I love how everything is nicely laid out for us. That makes it so easy. Vertex is up here at 1, 5. And is this vertex a minimum or a maximum? It's on top, so it's a maximum. And our maximum value is the vertex, so 1, 5. Our axis of symmetry, the line where the parabola is the same on both sides, it is going through the x-axis, so we say x equals, and it's going at about +1 right here. So x equals 1. Number 17, write and graph inverses. Write the inverse of the set of ordered pairs. Well, what does the inverse mean? The inverse literally means to switch x and y. So that's what we need to do here. Our first ordered pair is 4, -15. So our inverse of that would be -15, 4. Our next point is -8, -18. So we switch x and y. And the next one, -16, -2. And the last one, -15, +3. Now, which one of these answers matches that? D. Oh, did I do that wrong? Yes. Look at me making a mistake. Here's the -15, 3. Don't make that mistake like I did. These match. Perfect. All right. Number 18. Graph the inverse of the function below using the ordered pairs given. Then draw the line of symmetry to show that they are inverses. All right, so our 3 points are -2, 3. What's the inverse of that? 3, -2. And then 0, 2, the inverse of that is 2, 0. And 2, 1, the inverse of that is 1, 2. Now we need to plot those points. So we have 3, -2 here. Oops. We have 2, 0, and 1, 2. Now we can graph this line right here. Something like that. And then what line are 2 inverses symmetrical across? They are always symmetrical across the line y equals x. That was a question on your original test on the paper portion, and I was astonished at how many people got that wrong because I said that so many times in class. It was also on your inverse quiz. I asked you to draw the line y equals x to show the line that they are symmetrical across. So two lines are always inverses if they are perfectly symmetrical across this highlighter blue line, y equals x. Not any other line, just this line, okay? All right, number 19, solve for the inverse of the function f of x equals negative 2x plus 1. When we solve for the inverse, there are 4 steps. Step 1, change f of x to y. Great, that's easy. Y equals negative 2x plus 1. All right, step 2, swap x and y. Okay, so here we're going to say x, and here we will say y. All right, easy enough. Step 3, solve for y. All right, now we need to solve for y. What would be our first step in getting y all by itself? Well, we need to subtract the 1. And then last, we need to divide by negative 2. So we are left with y equals x minus 1 over negative 2. Our fourth step is to rewrite with inverse notation. And the inverse notation is that cute little negative 1. So we can say f of x, with the negative 1 in there, f to the negative 1 of x equals x minus 1 over negative 2. Let's talk about this because this was also a problem for a lot of people. When we divide an entire side by a number, both the x and the negative 1 are being divided by negative 2. We can break that up into 2 separate fractions. We can say x divided by negative 2, and we can say negative 1 divided by negative 2. So let's show that. X over negative 2 minus 1 over negative 2. Okay, let's simplify this. X divided by negative 2 is the same thing as saying negative 1 over 2x. There's always a 1 in front of that x, right? And let's keep those negatives in the numerator. N, negatives, numerators. All right, as for the second fraction here, negative 1 divided by negative 2. What's a negative divided by a negative? A positive. So now we have positive 1/2. So really, we can rewrite our function, our inverse function here, to say f to the negative 1 of x equals negative 1/2 x plus 1/2. All right, number 20. Composition of two functions. This is the stuff you learned this week. It says f of x is 5x minus 1, and g of x is 7. The question wants us to find f of g of x. Which function is going to go inside g of x? G of x is going inside of f of x. So I want you to see what I'm going to do here. G of x is 7. So we are going to take 7, and it is going to go in place of x. So how can I write this f of x with 7 where x is? We're going to say f of g of x equals 5 times 7 minus 1. And we simplify it. We will need to multiply 5 times 7, which is 35. And 35 minus 1 is 34. So our final answer is f of g of x equals 34. All right, let's take a look at number 21. Here it gives us f of x and g of x. The problem wants us to find g of f of x. So which function's going on the inside? F of x is going on the inside of g of x. Where? Where on the inside? What do you mean? It goes in place of x. So let's go ahead and start with writing our g of x. G of f of x equals, and then we start writing g of x. 7, that's where the x would be, plus 2. But instead of x, we're putting f of x, which is x minus 10. Oh, I did the wrong. Minus 10. And then we simplify. 7 times x, 7 times negative 10, 7x minus 70, and that plus 2 comes down. What else can we combine here? Are we done? No, we are not done. Negative 70 plus 2, negative 68. That is our answer here. Why can't we combine 7x and negative 68? They are not like terms. The 68 does not have an x. 7 does. So we cannot combine them. All right, that concludes our retest for the day. If you need more practice, please ask your teacher. I'm sure we have plenty of extra practice you can do. Between this test and the other test that you already took, we are going to take the higher of the 2 grades. Okay, so please study and do your best on tomorrow's exam.